Man, that was a rough producering. Sorry
It's a
about that,
rough
everybody.
transition,
Welcome.
Scott.
Yeah. Welcome to Into the Terminal, everyone. Uh, Today we're going to be talking about DNS, and this is actually because our last show, somebody's like, "Hey, can you guys do more on DNS?" And I was like, "Yes!" And then we
Yes,
got
we
back
can.
from our holiday, and we were like, "Oh crap, we said that we were going to do DNS." Excellent. Um, so yeah, we're gonna talk about DNS today, and we're gonna talk about some of the contents of DNS servers, and more like generally, like DNS is one of those services that few people don't really understand or few people really understand the ins and outs of it, and I think
Yeah.
that's one of the reasons why we see so many outages and things caused by DNS.
Well, it's
And so for
the level that we're going to show you DNS at today is commonly masked from people who, even if they're managing their own domain names at this point, because you've got some third-party solution that's basically managing your DNS server for you, whether it's a cloud provider or like even a network device, right? A lot of network devices, you buy a network device, it does DNS for you, and it gives you a nice UI that you can manage DNS. You don't have to get into the nitty-gritty. We're showing you Bind today, which is like the granddaddy of DNS.
Yeah. But honestly, like Unbound works in much the same way. That's the
Yeah.
new implementation or kind of like newer implementation of name services. Um, DNS Mask is one that's bundled with a lot of stuff. It works very similarly, but like the core tenets of DNS are identical across all of them in terms of how it operates. Um, but just to like give us some like expertise, Nate, uh, what is your expertise with DNS and how did you get it?
Oh, so I mean, my gosh, if we go way back to like the early 2000s, I was working help desk at the time, and I wanted to get deeper knowledge of like server side things because I did not want to work help desk my entire career, and I wanted to be a systems administrator, a network administrator. So I stood up my own website. And at the time, it wasn't as easy to just go to a third party provider and say, here's my domain and I'd like to run DNS. So it's like I had to beg a friend of mine to run secondary for me. And then I had to figure out how bind worked. And then I had to register a domain and, all those things. So that's how I got started with DNS, which really gave me a good foundation of what the heck is going on. But then as my career went on, I had a bunch of basically every job I've held since then has had some component of DNS, even if today that's just giving demos to all of you for DNS. But I worked at a web host for a while where we had several thousand DNS zones that I had to manage. And when I worked in higher ed, we had, of course, the one zone, but it was very large and complicated. So,
Yeah, and I actually ran DNS for a huge media conglomerate, and we had about 100,000 domains under management. Um, so we would get queries to stand up new domains and make changes to domains like all the time. And part of it, I think, or part of the reason why DNS it causes so many problems is one, people don't necessarily understand how it works and how it operates. I think the people that run the DNS at large companies tend to understand that, but I think the people making the requests don't necessarily understand that. And so they get like weird, unexpected results when they're like, hey, add an A record that says this. And you're like, okay, I'll add the A record. And it turns out that there's already another one in there and weird stuff starts happening because of that. And so as a DNS administrator, one, you have to have a really good understanding of how DNS operates. But then two, as you're getting those requests in for making changes to DNS records and zones, you have to actually like inspect what the current state is and then compare that with the thing that was asked and maybe almost entirely add to follow up with the requestor to be like, hey, I just want to confirm when I looked, this is the state of the thing, and you want to change it to look like this
right.
before I actually put any changes into effect. Because oftentimes they're like, oh, no, that's not what I meant. Um, so, yeah.
I meant the
Anyway,
thingamabob should point to blobbity blue.
right.
Okay.
Because it would be things like add an A record. And really what they want to do is replace or update an A record.
Yeah. Right.
Right. Which
Right.
is a very different thing. And they'll have a very different outcome at the on the other side.
There's a special language you have to use when dealing with DNS administrators.
Yeah. They're very precise. All right, so Nate, we're going to do a demo. What are we doing?
Yeah. So we're going to start with some basics, and in the deeper dive, we're obviously going to go deeper and talk about some of the stuff that we're introducing to you in the basics here at the beginning. So, come on, Scott.
I'm failing at producing today, man.
Oh,
Oh, I know
here.
what the problem is.
There we
go.
go.
Oof.
There we go.
You got to click the right
Come on,
buttons.
Scott. Come on, Scott. All right. So, first, what we're going to do is just like a very basic, what does a DNS query look like? And I'm not just going to do the query and say, yay. We're going to talk a little bit about what's going on when I do this. So I'm on a simple host here, is just a Linux box. And we're going to look up a domain that I've set up for my demos today. So we're just going to go host www.example.com. I kept typoing this in my practice. So if I typo it, it's going to happen. All right. So, and what this did is, of course, it gave us the website address. Now, there's nothing really spectacular to that. Basically, what happens is when you ask your system to resolve a name to an IP address, and that's why all this exists, because numbers are harder for humans to remember than names are, right? And that's exactly what the domain name system does. It takes a name, translates it to a number, so that humans can more easily interact with these computers. So what this does is your machine, whether it's a Linux server or your desktop or your smartphone or your fridge that connects to the internet, it has a default resolver or a default name server configured within its internet settings. And usually that's given to you by like a DHCP server. You plug a thing into the network, it gets an IP address automatically. Along with that comes its gateway and its name server address. So when I ask this system, hey, what does www.example.com resolve to? It looks to its default resolver and asks it, what does www.example.com resolve to? And in this case, if I look at, should be in etcresolve.conf. So in etcresolve.conf, I have two in there, which could cause confusion later. Hopefully it doesn't. But the 10.0.0.172 is actually an authoritative name server that I've set up for my demos today. Now, the secondary one is actually the one that was handed to it from my home lab network. Hopefully it never gets to that one. The reason there's two is because if the first one is down, my system will wait a predetermined amount of time for that request to time out, and then it'll fall over to the second one. That'll make resolution work, but it will make everything painful. Okay. I've had cases where my primary name server was down in like a network scenario, a larger enterprise, and everything was painfully slow. And everyone's like, why is everything slow? Well, that's because the first name server was down, and every DNS query had to wait the 10 or whatever seconds for it to time out on the first one to fall over to the second one, right? So that's something to watch for when you're troubleshooting DNS, right? Because that's exactly what this episode is about today.
So Nate,
all right, so
you used a term when you said what it was. You said that 10.0.0.172 is an authoritative name server. What does that mean?
So an authoritative name server is essentially a name server that hosts a domain name, the zone for a domain, right? So in my case, example.com, all the configuration for example.com is on that 172 server, right? And I actually we'll show it to you in a second, because I'm going to actually make a change to that record and show you, kind of how quickly that happens. Now, I have a second host here. So an authoritative name server is that exactly. Now there's also secondary servers, which are meant for failover purposes. And then there's DNS cache servers or recursor only servers, right? And that's most queries go through a recursor or go through a cache server, right? Because that's just kind of the way DNS was designed to work. Maybe you'll show that to us in your whiteboarding later, Scott. But so here's the zone file for example.com, right? And you can see down in here, I have a text line here that says www resolves to this 10.0.0.80. Of course, I picked 80 because that's the port that web runs on, but that has nothing to do with the IP address. Right. So in here, if I were to change this 10.0.0.80 to 10.0.0.81, right? Now, There's some nuance here when you're editing a zone file. Normally, and it's really good practice, one might say required, whenever you change something inside of the zone file, you also need to come up here to the top where it says the serial, and then you have to change the serial, right? You have to increment it at least by 1. It has to be higher than it was when you entered the file. So we're going to change this 3 to a 4, right? And we'll talk more about serials, I think, later on in the episode. For now, just realize that this has to be done. So we're going to save the change, and then I'm going to fully restart named. You could just reload it, but I had better luck with restarting because of the mass number of changes I'm making during these demos. Now, if I go back over here and I query example.com again, I get .81. Now, another thing I wanted to show you before we got into the deeper dive was I have a second system here. Okay. Now, remember I told you about authoritative versus recursing or caching only name servers? I also have a caching name server set up inside of my environment here. So this one, this -1 server that I was doing my first examples on, this talks directly to the authoritative. I'm going to say 99.9% of requests that you're making from a client do not go directly to the authoritative name server, even if you own that name server. You almost always have a caching or recurse only name server in the middle, right? Because that's just the way you protect your name server from being overloaded with requests. The caching name servers are there to do exactly that. They're made to look up queries and cache a copy of that query locally so that the next time someone asks for that thing, they don't have to go back to the authoritative name server every single time. So I set up a recursive name server in here to show you one of the downfalls to that. Notice right here, I did the same lookup. And what address did it give me? Even though I've updated the zone file, right? I updated on the authoritative name server. And on this machine that's talking directly to the authoritative name server, it gets the new IP address, the .81. On this machine that's using a DNS cache, it's getting .80 because that's the old address before I made the change. And this is a thing that commonly causes issues or confusion even, or sometimes prolongs outages even after an issue's been resolved, because that DNS cache is usually intentionally sent high enough that your authoritative name server is not getting beaten up with requests, right? Sometimes these are as long as a day or longer, right? Usually I set them for like half a day or a day. But if it's something that you know changes frequently, you definitely have to make sure you set that time to live or the caching number lower, right? And we'll talk again a little bit more about that as we get further on in our demos.
Yeah, and so to that point, whenever we would do like big DNS changes or like structural DNS change, for example, maybe we were moving an application from one server to another server. And so we'd stand up the second
Right.
server, we'd install the application, we get its data all going, we'd verify everything's working. And now we need the host name to go there instead of the original server. First thing we do is we'd go into the DNS record for that domain and we change the cache time to be really small. And we might do that like a week before our planned swing over to the new system.
These two entries that I have right here, I have actually set up for another demo, but you notice, so a normal entry, I have the host name, and then I just have, these other pieces of syntax, and then the IP address where it's supposed to resolve to. On these two, I have this additional number in here that tells it for these specific records to set that time to live shorter. Right now, in this case, I think that's only 10 seconds, right? That's not milliseconds, right?
That's correct.
Seconds.
That's 10 seconds.
So every 10 seconds, DNS cache on all of my caching name servers will dump the cached entry it has for server.example.com, and then the next request will go back to my authoritative name server. That's not great for performance, but it is great if you know the DNS is going to change really frequently for these hosts.
Yeah, and so what we would do is we would go in and we'd like edit that time to live, the TTL, for the record to be something small, like 30 seconds, so that when we actually did the swing over and we changed the record at most we'd have to wait 30 seconds for all the cached entries out there to pick up the change. And then once we had let it kind of bake and we'd take an extra hammering for about a day, then we'd go in and we'd adjust the time to live to normal so that it would persist in DNS caches for longer. And Nate, I did want to point out, you said that the other lines don't have it. They actually do have it.
Right.
It's
It's just
just not
to the default.
reported.
Right. It's
Right. And
I
so if you
meant it
scroll up in your
in
list,
text that's in here, you don't see it because what it's getting is it gets the default from up here in this upper block. I think it's the refresh here,
yeah.
right?
No, it's actually very up at the top. The first line.
Oh, up here. This
Yeah.
one. All right.
The default time to
Default
live for
TTL
any
for this
record
one.
in this is 2 days.
Right.
So for all these other records, if we made changes, uh, anybody that had looked up the record prior to the change, they could potentially be holding on to the old data for up to 2 days.
Right.
And so if I know that my timeout is 2 days, then at least 2 days in advance of making those changes, I'm going to come in here. I'm going to make the time to live something small for at least the records I'm going to be administering. Then I'm going to wait for the 2 days for all that cache to expire, and they're going to get on the short time to live. Then I can go ahead and process my change and be fairly confident that within a short amount of time, everyone will now have picked up the change in their cache.
Right.
And this like mechanism of caching, so many people don't get it. They're like, well, I made the change.
Yep.
Great. Did you make the change on this other guy's computer over there that happens to be using the cached record? No. So,
And the other snag is the TTL um it the counter starts the last time the request was made, right? So if I have two caching servers and this one requested the entry 2 minutes ago and this one requested it 2 hours ago, then the TTL on this one is going to be 2 hours shorter because 2 hours have already expired on that TTL, right? Than this one who just made the request, right? So this one will start responding with the newer entry sooner than this one. And that'll cause confusion for people as well because they're like, well, it worked here. Okay, well, that's a machine that you've never done that query on before. And it's updated because it never had any cache, right? That sort of thing.
right. All right. So, what else do you have for us on the critical path, Nate?
So I think that was primarily it. I went a little bit off script, but I think we covered everything I wanted to cover.
Right on. Well, for those of you who watch regularly, don't forget to like the episode. If you are a new viewer, feel free to subscribe to the channel and you'll get notified when we're doing new episodes and the like. We'll also post shorter videos and other things to the channel too. Today, we don't have a sponsor. I don't know why. Nate, I think our
It's because
sponsorship department is
it's because nobody's buying no one's actually sending money to our sponsors. I mean, come on, people.
like Nate's Subterranean Hosting.
Are you suggesting that $1 million is too much money? I mean, come on. We
Maybe.
get
I don't
like
know.
a meager 0.01% of that cut, which is probably still a lot of money when you're talking about $1 million, but
Meager. Um, cool. So that's a little bit of overview on DNS and records, and we'll do a few more examples as well. But I also wanted to do a little bit of whiteboarding because one of the other things that I think people don't quite understand about DNS is kind of how it's set up to operate, right? So the top level name servers are called the root name servers. Right, they're the top level name servers out there on the internet, and you can often find these in a configuration file called named.ca, and you'll see them if you set up your own configuration file. You get some basic ones with either bind or unbound installations, and so they're just like big beefy boxes out there that are the roots of the internet. Well, they actually delegate authority to all of these subdomains that are underneath the DNS hierarchy, right? So out here are DNS servers that are responsible for all these domain extensions. And then out here under all these domain extensions, there's subdomains. Right, and so on. And underneath the subdomains are records. And Nate, what was another? Did you have like Scott and Nate? Is that one?
Yeah, I had one for Scott. I had mail. I had the NS server itself has to be declared in there. Some FTP servers. Yeah, you get the point.
Yeah. So essentially, when you're out here, let's say that we're in nateshosting.com. That's where your system is, right? So here's you.
And I'm very happy.
And you do a DNS query. It's going to go to your local DNS server. And so if you're looking up, say, www.redhat.com, your local DNS server is going to go, oh, yeah, I don't serve records for that. And it'll then either go up to .com, or more likely it'll go out here to the roots, who will be like, oh, you want to talk to this person. Who's like, oh, you want to talk to this person. And then it retrieves the record that you want, and it kind of passes back through. And as it's passing back through, it's getting cached. So the next time somebody looks up www.redhat.com from within nateshosting.com, nateshosting.com already has a cached record for that and can just serve it directly from its record, its cache, instead of having to traverse that big old tree of namespace again. And same thing happens if we asked for like, me.us, right? So it'd go up here to Nate's hosting, who doesn't serve the records for me US. It'd go up here to the roots, which doesn't serve the records for me US, but it does know who the US servers are, who then know who the me domain subservers are, and it grabs the record you want and then passes it back around, right? And it gets cached at every single layer, all the way up and back again. So that's like, I think, fairly straightforward. Where it gets a little bit crazy is reverse zones. And that's something we've not talked about yet. We've talked about DNS domain name zones. And it turns out there's another kind of zone that we can serve, which is internet address zones. Right. And they're actually organized the same way. Right. So up here are the roots of the internet. And then down here is let's do that. And then right, we could keep going.
Yeah. So if you think about it, an actual DNS resolution from a name to a number is usually what's called a forward lookup, right? You're resolving a name to a number. That's like the intended use case for DNS. It is a forward lookup. What Scott's depicting now is what we call a reverse zone or a reverse lookup, where you're like, what's the name for this IP address? I have an IP, and now I want to look up information as to what its name is. And these are used in a lot of cases for validating the authenticity of a domain, especially in email. Right? If your forward and reverse don't match, that'll sometimes cause issues with like spam lookups and whatnot. If you're running a mail server, that's the first one that comes to mind because I had a lot of headaches with that in the course of my career.
All right. So essentially the same tree gets set up for your IP addresses, right? Where you need to look up a record for, maybe it's this host. And so you don't know who that record belongs to or the host name for that person belongs to. So you go up here to the roots of the internet, who then goes to the DNS server that serves the 10 dot addressing scheme, who then serves, finds the one that's doing the 0 dot address subnet and the 0 underneath that. And then, I'm sorry, and the, 1 underneath that. And then down there. I may have added one more layer than I needed to here. But so essentially you traverse the same way. You go up to the roots and then you traverse your way down. Now, the thing that you'll notice as a DNS administrator is that when you're putting in these records, they're oriented backwards. So if I was to put in a DNS record for this guy, I would say that one is a pointer to that host name.
Right.
And then the actual domain that would belong to. Oh, nope, I wrote it the wrong way. Is this domain. 1.1.0.10 dash, dot in dash adder.arpa. So that's a dot and that is a dash. All right, so when we look at these records, they're always written backwards. And the reason for that is that when we look at host names versus IP addresses, their actual direction is switched, right? So when I look at this guy up here, this is the least host-specific information, right? .us, the super domain in which it belongs. And then I get a subdomain, and then this is the actual system host name. Right. So if I'm reading it from left to right, it goes from most host specific, its actual host name, to least host specific, the super domain in which it belongs. But if I look at the IP address format, it's opposite. Right. This right here is the most host specific information on the right side of the information I'm given. That's its actual IP address on the subnet on which it belongs. Right. That's the next octet less information, right? Kind of a subnet network. And that's additional subnetting. And then here, this is like the super network that it belongs to. So instead of writing two different directions of doing DNS record parsing, the original RFC said, hey, why don't we just use the same thing again? But instead of making us do two different parsing mechanisms, we'll instead force the administrators to write their records in the same way. Most host specific at the beginning, least host specific at the end. And that's why those reverse zone files, the in adder ARPA zone entries, are always written backwards and look backwards, is because they use the same kind of style of going to the roots of the name server and navigating the trees of DNS to go and get the record that resolves to this thing. All right. So that's one of the weirdnesses of DNS, and that's probably too deep. I probably went too deep, Nate. What else can
I
I?
said we were going to go deep.
I did. What else can I solve for whiteboarding today?
I think you covered the most of the basics. Maybe, well, I guess you kind of covered the DNS cache stuff. Yeah, I don't know. Any questions in chat? I don't. There were some comments about your handwriting. They said we needed a pharmacist to be able to read the whiteboard. And I said, just wait until I man the whiteboard someday, and Scott's handwriting will look like poetry.
I will say Red Hat does not employ me because of my handwriting or artistic ability.
I always
That's
say
for
that
sure.
there's a reason that I chose a career where I'm at a keyboard.
Exactly.
What about different DNS record types? We will be talking about record types at some point.
Well,
We could
and
talk about
actually,
them now if you'd like.
yeah, let me pull that back up. All right, so Nate, what are some record types that you like?
So some of the most common ones would be an A record, a CNAME record. Oh, sorry, go ahead. Okay, a CNAME record. One that's becoming a lot more common is the quad A record.
Yep.
And I guess text records, TXT records would be probably the next most common thing. Some people, when you're really getting deep into DNS, SRV records are also important.
Is that a service record?
Yeah, so you can say like, oh, the LDAP server or the Kerberos domain is over there, right? And what port it runs on. So like email auto discovery will use SRV records. Oh yeah, the NS record. Um, identity domains like Active Directory and IDM, they both use SRV records to get things. Yep, MX record. There you go. And the start of authority, right? You're running out of whiteboard. I hope you don't have any more you wanted to list.
I think these are the big ones.
Yeah.
Um, and some of them are required. So, for example, when you're doing a DNS zone file, when you're defining a zone of authority, right, that your DNS server is going to serve,
Mm-hmm.
you have to have a start of authority record.
Right.
And that has information in it like the serial numbers that we are talking about earlier and the cache timeouts. But it also has things like the uh, domain name that you are authoritative for. It has
Yep.
things like the. Yep, go
If we
ahead.
switch to mine, I can show it in my zone file here.
Yep. I have too many screens, Nate.
And a whiteboard to manage. Let's
Yeah, so actually right up there at the top, the at
that wasn't
in
it.
SOA.
Man, they moved around the we have too many because of your whiteboard. Oh well, we'll just have to deal with it. So
there we go. Problem solved.
there we go. So this whole block right here. That's the start of authority. You notice it's got this open paren here. So that means it includes this whole thing down here, right? That's and most of this is information about how we handle this zone, right? So the start of authority tells it things like what is the name server that should be serving records for this zone, right? So ns1.example.com, and you notice that down here I have an A record for ns1.example.com in case someone needs to look that up. This hostmaster.example.com, I believe that's meant to be how you contact the hostmaster for this DNS record. No? Okay, go ahead, Scott.
That is
Tell
the
me.
secondary DNS server for this domain. All domains are required to have a primary name server and a secondary name server.
Yeah.
And so,
Well, that would normally be defined down here with the NS
so
record.
those are the name server records, but actually in the start of authority record, you also identify the primary. Oh, you're right. You're right. It's
Yeah.
the email address of the person that's responsible, but there's
Yeah.
not an @ sign in it. Yeah,
No,
my
there's not
bad.
an @ which is why it's always weird. You look at that like, what does that mean? And I think that people are just meant to translate that in their head, or maybe there's something automatic that'll do it for you. I'm not really sure. Okay, and then the serial number, which we talked about a little bit in the critical path. This is how other zones, or I shouldn't say other zones, this is how other name servers, especially things like your secondary name server, know when you've made an update to this zone. After you've made a change to this zone, you must make the serial number at least one digit higher. You must add one to the serial. So in my case, I have this formatted like year 2025, month 12, day 05, and then an increment number at the end. And usually I make that 2 digits because that will allow you up to 99 changes in a day. If you're making 99
Yeah.
changes to your zone file, then I don't know what you're doing. But
And that's actually the more standardized way of managing
yeah,
it. That
this is
way,
sort
when
of
you
the
make a
standard.
change, you just put in your today's date. The final two are your iteration number, right? How many changes you've made
Right.
today. You can actually make
Right.
that a 3-digit, right? So if you
You
made your
could.
100th change today, just put in 100. And that would also do it. The secondary name servers call in periodically and will compare the serial number they have on record with this one. And
Right.
the only thing they're looking for is this one integer wise a larger number
Right.
than the one I have? And if
Right.
so, then it's newer and I have to transfer it. So I've also worked
So
places where they just use like 1, 2,
yeah,
3.
yeah. And
That
a lot of the
but it was
automated
terrible.
systems that I talked about earlier, things that are managing this for you, where you're never in this zone file, you never see the serial number because it's managing it for you. So it just picks a number. It might start at 0. It might start at today's date and just work up from there, right? So you might see some really insane serial numbers if you're looking at zones that are not managed by humans, right? If there's no human that's managing that serial number, right? It could be that you imported the zone when you moved from bind to, appliance XYZ, and it brought in the date stamped one that you were using in bind. And then it's like, I don't care about date stamps. And it just adds one every time there's a zone update. So, there are some limitations here. And I don't know if these are still all true or not, but if this number changes too greatly, and I don't remember what the too greatly number is, then it will actually be rejected by some other name servers, right? We ran into this when I was in higher ed. Somebody had typoed the serial number in our zone file, and they made it, I forget what they did. It was still a valid zone file like serial number, but it didn't match our standards. And we knew that was going to cause problems later. The way to fix it, we figured out, was there's an upper boundary to what these can be. It must have to do with the size of the integer or something. And what you can
Yeah.
do is you can increment this serial number up by X number per day until you reach that boundary, and then it resets to 0. And then you can go back up to where you wanted your serial number. But you can't just go right from where we are to the upper boundary, because other servers will be like, something's fishy there, and it won't accept it. So keep that in mind.
That sounds very much like a old school 32-bit integer versus 64-bit integer problem.
Could
And
very well.
a million years ago, we struggled with that stuff. I think by and large, we've eliminated a lot of those things
Well,
through
this was not that long ago. I mean, it was 10 years ago, but yeah. So at
hmm.
any rate, it is just something to keep in mind. You should not be changing your zone file by your serial number by that many in a single edit anyway. If you're making reasonable changes to the serial number, it should never be a problem.
Well, while we're here, so there's
Yeah.
other things in your start of authority. We don't necessarily need to get into them. Um, Refreshes, how often your secondary name servers should try this one to see if they are out of date and need to sync a new update. If you're doing zone changes, this might also be a thing you want to make smaller because you want those secondary name servers to pick up changes faster.
Right.
Um, the update retry, if the secondary name server tries to contact your primary name server and it's not able to, it's going to try again in this example 15 minutes. The M there indicates minutes. If the secondary name server has been trying this primary name server for 4 days and it has not been able to contact the primary name server to validate that it has correct and up-to-date records, it will stop serving this zone. So that expiry time, that's for the secondary name servers. It'll simply drop the records for this zone from its serving if it's not been able to validate the primary name server for 4 days. And then the minimum is it's been a minute. Do you remember this one, Nate? Because I can't pull it out of my brain.
Minimum.
Oh, I think that's negative time to live, maybe.
I'm not really sure. Is that the minimum amount of time where a secondary is allowed to check in? No, that can't be right because the update retry is only 15 minutes.
Yeah, I think that may be the
I
negative
forget.
time to live, which is if someone looks up a DNS record for the zone that doesn't exist, then we should remember that answer for this period of time so that when they ask me again for that thing, I can immediately serve it out of cache instead of having to navigate the records again. Also, in Nate's example, you see a name server. Every
Hmm.
zone needs to have at least one NS name server record, but
Yep.
you can't have more than one. So these would be all the name servers that serve records for your zone.
You generally should have two, and most registrars will require you to declare two when you register a zone, when you register a domain name, which is why I had to beg a friend back in the early 2000s to do secondary for me.
Right. The down there you have the mail exchanger records, the MX records. So when we're sending email, these are the
Yep.
servers that serve the email for this domain.
And
So
another interesting, sorry, go ahead.
one of yours has a time to live that's specified. So
Yep.
that one, if somebody looks it up, it'll stay on their cache for 3 weeks instead of the default, which was 2 days. And
And that
then
was just
Nate,
an
you were going to talk about
example that came in with the zone that I copied as my example domain.
and then you were going to talk about the name or the mail exchanger value. That's also an additional
Yeah.
field of this record type.
So this isn't necessarily just for the mail exchanger, but it's called a priority, right? And if you have records that are multiple of the same type, right? So if in this case, if someone were to ask, where should I send mail for example.com? My name server will send them both of these back, right? It'll say mail.example.com, mail.example.net are the places where you should send mail for this domain. But the priority of those is you should send it to the first one first, mail.example.com, because that's a lower priority than the second one, right? However, if it can't reach the first one, it should default to the second one. And different things will handle that number differently, right? So you're talking about an email exchange there. That's logic that's kind of built into the mail exchanger or the MTA that's delivering mail, right? But there are other cases where you can specify a priority on different types of records that are within your zone file as well. It's the exact same format.
Yeah. And so for the priority, the lower the number, the more important it is.
Right.
So
Right.
mail.example.com is the preferred. If you're unable to contact that machine, mail.example.net is your fallback, right? Because it
Right.
has a less important priority.
What I used to see back in the early days when spam was so rampant, and I guess it still is today, but not everybody had a spam filter where they were filtering spam before it hit your incoming mail server. So what you would do is you'd add another MX record with a lower priority that goes to your spam filter. But then spammers figured out that if they just looked up all of the records for your MX, the higher ones in the list were probably not your spam filter, and they would send directly to that, circumventing your spam filter. So then what you would do is you would take your mail servers out of the MX record, and you'd only have maybe one or two spam filters instead of two records that go directly to your mail server. So, again, ways that DNS can be kind of abused to hurt you. Because remember, all of the records that are in here, if someone knows what they're looking for or how to pull your zone, they can get this data, right? So nothing in here is secret.
All right. Yeah. So I don't see any CNAME records in here.
Yeah,
Oh,
I have
wait,
one way
there
at
you
the
go.
bottom. I made one
Okay.
just for fun.
So CNAME, it stands for canonical name, but essentially it's an
Right.
alias record. So
Yeah.
in Nate's case, ftp.example.com, when somebody asks for ftp.example.com, we'll tell them that they need to go to ftp5.example.com, which is going to kick off another DNS entry or another DNS lookup for ftp5.example.com. And then they'll get the IP address that they need to talk to.
And it
right?
comes
And you
back
can
and
see
pretty
here,
clearly tells you that it's an alias, right? It's an alias for ftp5.example.com, and then it does the lookup for ftp5.example.com and gives you the IP address for that.
yeah. And so, Nate, if you did I don't know if your name server is able to do external lookups, but if you did a host for www.google.com,
I have no idea if this will recurse or not. It will. Look at that.
okay. Mine, when I do this, it actually comes back with a ton of CNAMEs. Like,
Okay.
and that's how Google is kind of like managing their load balancing to different hosts. And I
Yeah.
see you're
So,
using round robin DNS. CNAME based DNS is another like way that you could do it.
yep.
But when you
Yep.
have multiple records of the same type for the same value, right? So in Nate's case, they're the server records, or the two records that say server, that's the same value. Um, so when you do a DNS lookup against it, you get these records. Because we're using a DNS tool like host, it gives me all of the records. But if I
Right.
was using something like wget or curl, it would do a DNS lookup and it would grab one of them, and that's who I'd talk to.
See, I
Right.
tried
So
to
you can
ping
see
it
that
here and
it's
it got .7.
yep.
And of course, it can't get there because that host doesn't actually exist. Now, if I did it again, it might get .8. Maybe not.
No, it's good. Well, you have to wait until your
.6. There we
cache
go.
expires.
Well,
Yeah.
it caches both, right? And then I don't know how it decides which one to reach out to each time. Oh, no, that's right. It's only a 10-second cache. So you're right. It was when the cache expired.
Yeah. So your client that's not a DNS client, right? Your client,
Right.
which was ping, uh, did a DNS lookup. It got .7 and used it. And then when the cache expired and it did another DNS lookup, the DNS server provided the other one. And essentially, what will happen is it'll just kind of like alternate between the A records, for each host that connects. So sometimes you might get 7, sometimes you might get 6. It depends on how many other people are doing that query too, to see, like, because the name server just serves them out serially, or yeah. So if you did it here, I would expect that you'd get whichever one is handed to you first, and then you're just going to wait 10 seconds and give you the next one, and wait 2 seconds and give you the next one. And the reason for that is that nobody else is also banging away on your name server to get it to advance the round robining. You're the only
Right.
person that's advancing in the round robining.
Right.
In real,
Right.
you could get the same one over and over and over again, because it just so happens that other people were also hitting it the second time and the third time. And the DNS server, by the time it got back around to your request, we're back at the top response again.
Right. Now, this turns into one of the troubleshooting things we wanted to touch on, which was if I'm in here and someone asks me, I need an A record for scott.example.com, and I just come in here and quickly, add a new line and, I don't know. What's your favorite number, Scott? How about
17.
9?
Okay,
17.
9 it is.
Okay. And then let's go back up and update that serial. Right. So now what I'm going to end up with, as you might expect, is when I look up scott.example.com, it gives me, well, oh, it must be cached. Let me do it on this one because this one's going directly to the authoritative. It'll give me both addresses. And that might be unexpected behavior because the person who asked said, I need a new A record for scott.example.com, because they did not know that scott.example.com already existed. They didn't do their homework, or they don't care. They just made the request because you're the DNS admin. You're supposed to know these things. And then you were in a hurry, so you came in and added scott.example.com, assuming that they did their homework. And now you end up with this confusion. And whoever is legitimately trying to get to scott.example.com is now getting 2 addresses instead of 1. The person who asked for it is getting maybe the wrong address, and they think you're an idiot, and you think they're an idiot, and it just leads to a bunch of problems.
And this is actually more insidious than you think, Nate, because what will end up happening is half of the people, when they go to
Right.
scott.example.com, go
Right.
to the new place, and
Right.
half of the people go to the old place. And so if it was like they turned off the old server, half of them are getting the response they expect, and half are getting like a timeout or something else. And so this becomes a really difficult thing to troubleshoot because it's kind of working, or it's working for these people, but not those people. And you have to
Right.
figure out why that is. And so this is one that I used to run across all the time, where somebody say,
And
add this A record, and I'd see that there's already an A record, and I have to respond back. Do you mean that you want another A record so it'll flip flop between these two?
right.
Or do you mean you want me to update the existing A record so that it now has this value? And almost entirely it was, oh no, I meant update the existing A record.
Right. And this is one of those things that makes DNS such a tricky thing to, I shouldn't say tricky to troubleshoot. It's the last place people look, right? Which is why we have the DNS haiku. It can't be DNS. It's not DNS, right? Oh, it was DNS. Well, that's because everyone assumes that DNS, if you got a resolution, you're like, oh, DNS must be fine. But when you dig a little bit deeper, you might find something like this, where DNS is 50% of the time giving you the wrong address because somebody messed up and added a second record for scott.example.com.
Yeah, exactly. And that's one of the reasons why I like CNAME records, because CNAME records actually tell you that they're an alias to another thing. And that way, if you have multiple CNAME records to the same host name or to like different boxes, you can then make sure that the CNAME records kind of direct you where they're going. And the value assigned to the CNAME record tells you very explicitly which box it's actually being sent to, right? And you can kind of manage it by this alias name. Yeah. You
I
don't
have another
have a
fun one.
reverse.
We have like
Yeah, yeah.
just enough time for, I think. And this is, you can add records that include a dot in them, right? So you can do like, I don't know, server dot cluster2, right? Wow, we'll give it 5. Right. And what that'll do is server.cluster2.example.com will now resolve to that IP address. Right. Which, great. Sometimes that's useful. So you can also make another block in your zone file that is for cluster2.example.com. And then hosts that are inside of there will default to that subdomain or whatever you want to call it. Right. That domain within a domain. But you can also do things like, let's go server2.example.com. We'll reuse 6, right? And this is actually valid syntax, but I intentionally made a mistake here just to show you guys. Let's go back to my serial number here.
Oh, by the way, Nate, did you know that if you restart your name server, regardless of the serial number, it'll recache all your records?
Yeah, but I'm trying to keep the habit. I'm trying to make
Okay.
sure people understand how important that is. Most of what I'm doing here today, the fact that I'm updating the serial number has absolutely no bearing on whether these are going to work because I'm not actually caching. I'm not sending to a secondary name server, right?
Right.
So anyway, so I added that in there, right? Now, if I go over, let's use this one because there's no cache to worry about. If I do a host, what did I call it? Server dot, what was it? Cluster2. This one should work, right? Address 10.0.0.5. What was the other one I added? It was server 2 or server 3?
Server 2.
Server 2. So if I do host on server 2.example, this actually does not work. And the reason it doesn't work, watch what does work. Come on. My fingers are getting tired. What does work is server2.example.com.example.com. And that's because every host that's in here, unless you tell it otherwise, it's going to assume it is a host within example.com, right? So server2.example.com, bind is reading that as a host inside of example.com, server2.example.com.example.com, because it's appending the zone file or the domain that this zone file hosts. Now, Notice up here, we specified an entire domain name and we have a dot at the end of it. The same thing is true down here with our CNAME. There's a dot at the end of this as well. Now, if I specified the CNAME without the dot, I think it would give me the same problem where it would append the example.com to the end of the CNAME, right? So the way we get around that, it's perfectly valid if you, for some reason, want to include the fully qualified domain name in your zone file, you can, but you have to add a dot to the end of it. And this is another really common mistake that people make. They're like, well, I specified the whole domain. It should be completely fully qualified and it should work. But Bind doesn't look at it that way. Bind looks at it as you've given me a host entry. I'm going to append example.com to the end of it. So now if I go back up here, remember that serial number. Let's restart named again. Let's go back to this one here. And if I look this up again without the extra example.com, now it works. So that's an important thing to keep in mind when you're specifying those things with a longer name.
And where I see that mistake made all the time is not that first entry in the file where you're specifying the host names. It's things like the data in your MX record,
yes,
or the CNAME record, where you're giving it an explicit host name and people forget to put that trailing dot. And so it automatically appends the domain name again to it. So I've less seen that in Nate's example of like putting it as a host entry, because most people end up not, they use whatever's in this file as kind of the template for how they're going to manage things. It's right. Yeah. And you just did it with mail.example.net there.
Yeah, we're going to see, because I'm going off script. I didn't test this one. So if I like dig, and then I want to tell it what server to dig at. No, it's using my default resolver. That should be fine. We're going to dig for the MX.
You need
it's been a while since I've dig.
TMX.
-t MX. And then.
Yep.
Okay. And now, yeah, see, here we go. The one I did not remove the dot from looks perfect. The 10 priority is mail.example.com. The one I removed the dot from says mail.example.com or .net.example.com because there's no dot. The dot is what tells it this is the end of the record. So
right. And do you remember when I was whiteboarding and I started my big tree with a box that just has a dot in it?
Yep. That's the root.
Why do you think I chose that? Because that's the very top. Exactly. That's where I need to stop.
It's the end of the road.
So, all right. So that was a lot of DNS, Nate.
That was a lot of DNS.
Probably not enough. There's probably people that are like, no more. I want SPF.
But you didn't cover this thing. That's my problem, and I want to know.
Yeah, we didn't cover quad A records or how to do like IPv6 stuff in DNS. We didn't cover DNSSEC, which is like
I turned all that off to get these demos to work. By the way, DNSSEC was giving me all kinds of nightmares.
Mine was fine.
Yeah.
But then my system evaporated though because it was ephemeral.
Okay.
I did have to apply updates so that I got the newer TLS, and then it was fine. But DNSSEC is SSL encapsulated DNS.
I think because I used example.com instead of a made-up domain name that didn't really exist, it was actually trying to validate DNSSEC for the domain, and it was failing. So I had to turn it off.
Fair enough. Example.com is actually a RFC defined domain.
I know, that's why I thought it would be fine, but it wasn't.
Yeah. The other thing we didn't talk about is network traffic. The fact that when you're doing DNS queries, oftentimes you're doing UDP-based traffic to your DNS server's ports. But when you're doing things like transfers between hosts, like between your primary and secondary name server, that's oftentimes using TCP-based connections. So when we're doing things like firewall rules for DNS, things like what type of network protocol it's using is important for your port 53 connections. So that's something that we didn't get into, but there you go. There's your little nugget. You need both UDP and TCP probably for DNS servers to be able to pass through your firewall. And then we didn't get into like a ton of the different options. In mine, one of the things that I found was my secondary name server was storing hashed values of the records. So when I was trying to figure out what records it had, it was not human readable. And so
That's
I had to
helpful.
update a config entry to like tell it to no, dump it out in text so I can read it. So there's all kinds of like weird things that you get like that with DNS too. But yeah, DNS. What are we doing next week, Nate?
We had a plan. What was it? Image mode stuff, wasn't it?
Is it? Hold on. I can
Thought that's
tell
what we
you.
were going to do. We actually have a plan for next week. Scott's just checking if my memory was right or not. I'm almost positive it's image mode.
Something bootsy something. So yeah, it'll be
right.
something to do with bootsy and image mode next week.
Yeah. No, so in my brain, it's going to be like, let's do some real world stuff with image mode. Because you've probably seen the demos like, oh, look, I pushed a new image to the registry and now I've pulled it. Yay. Yeah, well, that only gets you so far. Let's do some real stuff with image mode. And that's what I kind of have in mind for next week.
All right. And for those of you who haven't seen image mode or bootsy before, it's managing your operating system as an image, as like an appliance where you pull down a
Right.
whole new one and then boot into it. Although for RHEL 10.1, you don't have to boot into it anymore. As long as you're keeping the same kernel,
Yeah.
you can just like restart
Soft
all the
reboots.
services and it's super fast.
Maybe that'll make a showing next week. We'll see.
Right on. Well, I mean, bootsy something. The world is your oyster, Nate.
The world is my oyster. We will bootsy all the things.
All right. And then our last episode of the year will be on December 19th. And that's going to be me and my prior manager, Susan, talking interview stuff. Like what questions are you asked? What are questions we always ask? How should you prepare? That kind of thing. So if you're interested in more career advice stuff, interviewing for positions, what are things that hiring managers look for, at least the hiring managers that we work with here at Red Hat, that'll be our last episode on the 19th. So bring your questions for that one.
So you guys get more of Scott talking about career stuff because Nate took vacation.
Well, I mean, I could give them more kernel performance stuff because they love that
more
so much.
Scott's whiteboards. I hear people love
Everybody
those.
loves Scott's whiteboards. No, they don't. They don't. But that's okay. All right. So don't forget to like and subscribe. Well, it's also hard to like write on this tablet, right? Like,
yeah, no, I get it. I get it. My handwriting's terrible to begin with, but yeah.
All right. So join us next week for something bootsy something, and in 2 weeks for more interviewing and career stuff. And then we'll see you next year. But hopefully,
2 episodes in advance we have planned out. 2.
I mean,
and now the year's over.
I don't know what's happening. All right. So thanks everyone for watching, and we'll see you next week.